differentiation using product rule and quotient rule. Given y is equal to cos x cube into sine squared x power 5. Now clearly you can differentiate this using the product rule. Let me take u to be equal to cos x cube and v to be equal to sine squared x power 5. Now let us differentiate u using the chain rule. Let me take t to be equal to x cube. So dt by dx is equal to 3x squared. So u is equal to cos t. So du by dt is equal to minus sin t. Therefore, u dash is equal to du by dx, which is equal to du by dt into dt by dx, that is minus of sin t into 3x squared. Substituting back for t, I'll get it as u dash is equal to minus of sin x cube into 3x squared. Similarly, let us now do for v. Let me take x power 5 to be equal to t. So dt by dx is equal to 5x power 4. Let me take s to be equal to sin t. So ds by dt is equal to cos t. So v is equal to s squared. So dv by ds is equal to 2s. Therefore, v dash, which is equal to dv by dx, is equal to dv by ds into ds by dt into dt by dx, which is nothing but 2s into cos t into 5x power 4. Now substituting back for s and t, you will get it as 2 into, we took s as sin t. So sine of t is nothing but x power 5. Cos of t is nothing but x power 5 into 5x power 4. So this is v dash. Now by product rule, y is equal to, y dash is equal to dy by dx, which is equal to uv dash plus vu dash. Now we know u is nothing but, we took u is the given function, that is cos x cube. So cos x cube into v dash is nothing but 2 sin x power 5 cos x power 5 into 5x power 4 plus v is nothing but sin squared x power 5. Let us substitute the sin squared x power 5 into u dash is nothing but minus of sin x cube into 3x squared. Or finally, we get y dash, which is nothing but dy by dx is equal to, let me multiply, 2 into 5 is 10, it is nothing but 10x power 4 sin x power 4, sin x power 5 cos x power 5 into cos x cube minus 3x squared into sin x cube into sin squared x power 5. Now let us do this problem. Y is equal to sine of ax plus b divided by cos of cx plus b. We can apply the quotient rule here. Let me take u as this, u by b. Let me take u as sine of ax plus b and b as cos of cx plus b. Now We can apply chain rule here also. So let me take t to be equal to ax plus b. So dt by dx is equal to a. So u becomes sin t, or du by dt is equal to cos t. Therefore, u dash, which is equal to du by dx, is equal to a into cos t. Let me substitute for t as ax plus b. Same way, let me take t to be here as cx plus b. So dt by dx is equal to c. So now v becomes cos t. So dv by dt is equal to minus sin t. Therefore, dv by dx, b dash is equal to dv by dx, which is equal to dv by dt into dt by dx, which is nothing but minus of sin. Let me substitute back for t as cx plus b. Therefore, by quotient rule, y dash, which is equal to dy by dx, is bu dash minus ub dash by b square. Now let us substitute for b, u dash, u, b dash and b. So that would give you, so b squared is nothing but cos squared cx plus b. B is cos of cx plus b into u dash is cos of ax plus b minus, so u is sine of ax plus b into b dash is minus sine of cx plus b into c. Here also we have into a into cos x. So on simplification, we get y dash, which is equal to dy by dx is equal to a into cos of ax plus b into cos of cx plus b minus c into sine of ax plus b into sine of cx plus b, the whole thing divided by cos squared